What is it? There we go. Where am I gone now? Yeah, I think we're there now. Gosh. Just going back. Okay, so triple momentum. This is the first lesson in a series of lessons, really, which... let me turn the light on so there's better light in a minute. That's better. Which is quite a tough topic. There's a lot of maths required, a lot of rearranging, but we're going to take it step by step. This first lesson is kind of... We're going to use two methods, but you can see that the second method is going to be quite important when we come to doing different types of momentum, or collisions, I should say. So, as always, we've got your title, your keywords, and a bit of a starter. Now, the starter is linked with this lesson. It's not linked with other topics. So I'd like you to do a little bit of research on Google. Your keywords are conservation, stationary, and direction. And what I'd like you to look up is what is momentum. Maybe watch a quick video on it. What is the equation for momentum? I think you'll get that as you look up momentum. We're looking for this term conservation of momentum. You might have heard of the term conservation of energy before, and it kind of links with this topic. Conservation of momentum is what we're really looking for in this lesson. And there's just a challenge, just to test your math skills. I want to rearrange to make x the subject. So you've got y equals xz. You've got y equals x over z, and then you've got y equals z over x. I want you to have a go and try and make x the subject. Try and get x on its own in every one of those. So if you press pause and have a go at those now, please. My Apple pen. All right then, so I'm going to come to be answering the questions now in the next slides, but I'm just going to do this challenge because while I remain on this slide. So to get x on its own, you've got y equals x and z. Well, x is tied up with z, so I'm sure that you would have done this in maths where anything you do to the one side, you do to the other. So I need to get rid of z by here. I need to divide by z. So if I divide this side by z, and I divide this side by z, I'm going to get y over z equals x. Sorry, I was just checking... Yeah, so y over z equals x, or you could rearrange that, x equals y over z. So that's all I've done. I've divided by z there, and I've divided by z there, and I get z on the other side. So I've got x on its own there. This next one, y equals x over z. Well, this is fairly easy now. I need to get rid of this z, don't I, to get x on its own. So I'm going to multiply both sides by z. So if I multiply this side by z, I get rid of z. But now I'm going to get z, or yz, equals x. Or x equals yz. If you are struggling with this, I would recommend that you maybe email... your maths teacher and ask for some rearranging problems. There's plenty online. I'm not showing it the way that maths would because I haven't got room to show everything, but I hope you can see where I'm getting this from. And then this is probably the hardest one. I know I've talked to Mr. Woolley about this a lot, and he just says do the crisscross method where you just move x to y and y to x. I don't like that way because it doesn't really show you what's happening. The first thing I need to do is to get rid of x because it's underneath c. So I would multiply both sides by x and I would come up with yx equals z. And now I need to get rid of y on the x side, and then I would just divide both sides by y now and get x equals zy. That's the way I would do it, because that really, I know it's a two-step process, and you know the crisscross method works just the same, where you just replace y with x, but you don't really know what's happening there. And I think it's important, especially for this level of physics, to know what is happening. Again, if you're struggling with this, don't think, oh, I can't do this lesson, because you can do this lesson without knowing this, but you do need to practice, because this is the level we will be working at for triple physics. So let's just go through the learning objective just before I touch on questions 1, 2, and 3 from your starter. So we're going to be calculating the total momentum of moving objects that collide. And like I said at the start, this is the first lesson in maybe 3, maybe 4 lessons, because you got different types of momentum. You got elastic and you got inelastic, and then you've got objects that move off together and objects that go the separate ways. So really, I really like the subject. If you're good with maths, you'll really like the subject. If you're not good at maths, then you just need to get good at maths. Sorry to say that, but it's just one of those things that we're going to be doing. So your keywords there: conservation, stationary, direction, and then it's linked with your triple physics, further motion. Again, I do this topic right at the start. It gives you all year to practice these equations then, okay? So what is momentum? The first question that was on the starter there. Let me just make my face smaller. Move it up there. And I can zoom in on that then. So a moving object has momentum. This is the tendency of an object to keep moving in the same direction. It's difficult to change direction when there's a lot of momentum. So the best way I can describe that, if you're running down a hill and you try and stop, it's harder to stop than when you're running up a hill, okay? Because you got gravity acting on you, and you've got that momentum. So you're running down, and it's really hard to change direction quickly. Footballers are brilliant at this. I mean, they've really trained their legs really to be running at the speed and then stop and then just change direction. But a vehicle can't do that. Once you've got that momentum, and your momentum really is your mass, how much stuff is in there, and don't get confused with weight here, because mass is the amount of stuff, weight is the mass times the gravity. So your mass times your velocity. Now I'm going to introduce the word velocity. The velocity is the same really, use your V here. Your velocity is the same as speed. It's the same units, it's meters per second, but we're talking about vectors. So you got scalars and vectors, and if you've seen Despicable Me, you know the bad guy, his name is Vector, because he's got magnitude and direction. So magnitude stuff and a direction. So a velocity has actually got a direction. It's got north, east, south, west. Okay, and we'll do a little bit on vectors towards the end of the year, because it's just one of those things you need to remember for the exam. It's not really practice. Now, momentum can be calculated using the equation. So P, we use this letter. I mean, you could say it's rho, the Greek letter rho, but I'm just going to call it P because it's easier. P equals m times v. So I know it's a bit awkward. Momentum you'd think would be m because of momentum, but we've got this mass as well. So they use the letter P. So momentum equals mass times its velocity. So if you imagine a truck moving now, it's got its mass, whatever it might be, it's got its velocity, it's got its speed. The momentum would be the mass times the speed that it's going, and that is an easy way to calculate your momentum there. It says there that the mass is measured in kilograms. That's a standard unit for physics, okay? It's chemistry that'll be using grams. And then V is your velocity, which is meters per second. Your P, and it makes sense really, because if it's mass times velocity, is kilogram meters per second. Okay, that's your unit. I know it's quite lengthy, but it's a kilogram meter per second. That's all the unit is. Okay, and you've got the triangle there. I don't know if you've used triangles before. Yeah, you would have. Of course you would have. It's just an easy way to rearrange if your rearranging skills aren't there. And this lesson is very achievable. Oh, I'm pressing the wrong one. Okay. Now, before I answer the momentum, conservation of momentum, I just want to show you a quick example of that, how you calculate momentum. Because this equation, let me go back. This equation here, I should use this, is found in the front of your physics books, your exam, sorry. So when you get your exam, this will be in the front of your book. So you don't need to remember this, you just need to know how to use it. So this is a really simple question you'd get in a foundation paper. Okay, it's not going to be coming up on the higher, and if it does, it'll be part of a bigger question. What is the momentum of a 5 kilogram object with a velocity of 2 meters per second? So you can see there that I'm going to underline 5 kilograms, that's my mass, 2 meters per second, that's my velocity. Okay, I go to my triangle, my P equals mv, my m is 5, my v is 2, 5 times 2 is 10 kilograms per meter second. I hope you can see that. I did do that quite quickly, but I'm guessing at this level, especially triple, you're able to see that, okay? 5 kilograms times by 2 meters per second. 5 times 2 gives you 10. Okay, just as a quick practice then, you try one. Okay, what is the momentum of a 140 kilogram object? Could be a truck, could be a ball, could be anything, moving with a velocity of 3 meters per second. Okay, there's your equation, down by there, have a go. And that's what I've done. So I've picked out my my mass there is 140 kilograms, which is there. My velocity, my speed is 3 meters per second. What's my momentum? P equals mv. I've times 140 by 3. I've come out with 420 kilograms meters per second. So like I said, that's just a warm-up really to what we're going to be doing. We are going to be using that equation. We're going to be using another equation as well, hopefully. But it'll be your choice, and you'll see as we come to that now. Okay, so I mentioned direction and vectors before. Now it says there, momentum does not only depend on the object's mass and speed, but it's really interesting in the direction. So momentum of an object also depends on the direction of travel. This means that momentum of an object can change if the object speeds up or slows down, or the object changes direction. And we'll see that now as we come into practice. So I guess this blurb is just basically saying you're going to be dealing with directions, okay? It's really important when we come to draw our diagrams, which we will now in a sec, that we look at directions, because if it's going in a forward direction, it'll be a positive. If it's going in a backwards direction, so if two cars are going to collide, one of them is going to be positive, one of them is going to be negative for our values. And then we come to that conservation of momentum, which is very, very, it's identical to your conservation of energy, really, which you would have done in year 10. And I know it's been a bit strange this year where you haven't had to do the exam, but this is just a follow-on from the energy. So as long as no external forces are acting on an object, that means so long as there's no friction and there's no any other energies acting on it, the momentum stays the same in explosions and collisions. So we're dealing with explosions and collisions. We say the momentum is conserved. Now, in a perfect world, let's take gravity and friction out of it, okay? We're going to be doing Newton's laws in year 11 anyway, just all of science will. And this is one of those laws, it's inertia really, where an object will remain in constant motion or at rest unless an external force acts on it. And this external force, like if I chuck this pen, it's going to land on the floor and slow down because gravity pulls it down and friction makes it stop. If I throw this pen in space, it's just going to keep going and going forever and ever and ever and ever until an external force, something, acts on it. And that's all this means. So momentum is conserved. It means the momentum before a collision must equal the momentum after. That momentum, that energy goes somewhere. So the momentum before is equal to the momentum after. You can use this idea to work out the mass and velocity. And then I've just shortened this because sometimes for 2 marks you're asked in a exam, what is the conservation of momentum? Momentum is conserved in a collision or explosion when no other external forces act on it. So I guess 1 mark, you say that momentum is conserved, and another mark there for if no external forces act on it. So let's get into this then. Let's get into, and these are quite lengthy. So we'll just start with reading the question for now. So it says there, two carriages collide and move off together. Carriage A, which is the first carriage, has a mass of 400 kilograms and moves at 8 meters per second before the collision. Carriage B, which is the other carriage, has a mass of 500 kilograms and is stationary. So it's not moving at all. It's just there. What is the velocity of the two carriages after they collide? So in this case, I'm just going to underline they move off together. Now, all the examples we're going to be doing today, they're going to be moving off together. They're going to combine and move off together. And that is really important point, that is, because there are other collisions where they move off separately. So the first part of the success criteria, sketch the diagram before the event. So I'm going to do that by here, and I'd like you to do this with me, to be honest, because it's a tough process to get. So I'm going to go carriage A, or actually I'm going to go before, and then I'm just going to draw a line, and then after. So before the event is here, after the event is here. So I've got carriage A, I'm just going to draw it as a circle, and then carriage B. Okay, now remember, well, let's just give them some numbers a minute before things. So carriage A has a mass of 400 and it moves at 8 meters per second. So if I stick with the success criteria there, work out the total momentum. So I need to get some figures here now. So A was, what was it? It was 400 kilograms, and it moved, and I'm going to just pick a direction here, because it doesn't tell me which direction. But I'm going to pick a direction. This is a really important bit, that you draw an arrow, and it was going at 8 meters per second. Okay, so it's going this way at 8 meters per second. The other carriage, carriage B, has a mass of 500 kilograms and is stationary. So I'm going to give it 500 kilograms. And it's moving, okay, at 0 meters per second. I could have done the arrow any way I choose there because it's stationary, it doesn't matter. Okay, hopefully we're all right up to now. Now, after the event, they combine and they move off together. So I'm going to draw my diagram like this. I'm going to draw one A, B. It's one big circle. I know that doesn't look like a B. It's one big circle. Let me do that again. Let's get this right. That's better. A, B. Okay? They collide and they move off together. So they both got the same speed. Now I've got the mass now is going to, well, actually, let's just leave that. Let's do the success criteria. So work out the total momentum for the event for carriage A and carriage B. So the first thing we're going to do on this side, before the event, I don't want to deal with after the event minute. I'm going to work out the total momentum for each. And I can do that because I've got a mass and I've got a velocity. I've got a mass and I've got a velocity. And if we use the triangle, PMV, or you can look in the front of your books, your exam, and it'll be P equals M times V. I'm going to do this for each one now. So for this one, P equals MV. P equals, my mass is 400, and my velocity is 8. So 8 times 4, 32, 0, 0. Okay, and that's my velocity there. That's going to be kilogram meters per second there. I have to do this smaller now. I've taken up too much room there. So that's my momentum for carriage A going. My momentum for carriage B is obviously going to be 0, but we'll work it out anyway because it's not moving. There's no momentum at all. P equals MV. P equals, my mass is 500. My velocity is 0. So now I've got 500 times 0 is 0. So I've worked out my momentum for both carriages. I've got carriage A with a momentum of 3200. My B has not got any momentum at all. What's my next step? Because momentum is conserved, the total momentum before the event... Oh, hang on, I haven't done this bit. Carriage A plus carriage B. So I need to add these together now to give me my total momentum. So if you think, if I got two things moving and they collide, I got a total momentum there. So I got my total momentum, and I'll say this as PA, my momentum for carriage A plus my momentum for carriage B. This is going to equal 3200 for my A plus my 0 there. So it just equals 3200 kilogram per meter second. And that's because carriage B wasn't moving. All right? Then it says, because momentum is conserved, the total momentum before and after the event should be the same. So then it sketched the diagram after the event. Well, I've done that already because I'm so used to doing these. In fact, it's a little bit clunky because I'm referring to the success criteria all the time. You'll see as you get into the process of doing that, you won't really be using the success criteria. You'll just be using the method, just like you do in maths, really. It says work out the total mass after the event. Well, if I've got now mass, you haven't lost any mass unless the collision you start losing things. We're going to take for granted that everything is combining. So the two masses combine. So it's going to be A was 400 plus B is 500. So I've got a total mass now of 900 kilograms on this side. Now I can use my formula now, my triangle, PMV, to work out the velocity. Because I know my mass is 900. I know my momentum is 320 there, or 3200. Because momentum is conserved, the momentum must be the same after the event as before. It's just going to be a different speed. So I'm going to rearrange, so I'm just put my finger over V. Okay, so V equals P is on top of M, P over M. This is, so my P was 3200 over my mass, which is 900. Okay. In the calculator now, I would put that, and it comes out to 3.6 meters per second. And that is the answer. That is the answer. Now, that is the way that WJEC advised to do it. And I think that is, that's a lot of work for the 4 marks that you would get. I mean, it's fairly easy. You don't have to have any rearranging skills, apart from, putting that into a triangle. But there is an easier way. There's a much easier way of doing this, and it's the way I prefer, and it's the way that we're going to need to do anyway, because this method doesn't work for the rest of the collisions. It works for this one on an elastic collision where energy is conserved and they move off together, but sometimes they move off differently. And we're going to have to use a different equation anyway, and the equation is this. Now, I'm conscious that that's a lot to take in, and I'm giving you more here. Unfortunately, it's just the nature of the skills required for this. But the good thing is, it's guaranteed to come up because it's such a big topic, and you're going to get plenty of practice on it because we do this right at the start of the year. And this is not found in the front of your exam. This is just something you're going to have to remember. And it's M1. So let's draw a line under that because this is something complete. I'm going to do this again, okay? M1, U1. So my U, as we come to be doing SUVAT, you'll know that U is the initial velocity and V is the final velocity. Okay, so I'm just going to go M1, U1 plus M2, U2 equals M1, V1 plus M2, V2. Just let that sink in a minute. Mass of my first object, the velocity of my first object, mass of my second object, velocity of my second object. That's before the event. This is after the event. Mass of my first object, velocity of my second object, mass of my second object, velocity of my second object. Now, in this case, we've only got one object after the event. And I can simplify this now. I can say m1u1 plus m2u2 equals mv, because I've only got one thing moving off, they combine. Okay, so I've got m1 v1 plus m2 u2, I should say. So m1 u1, m2 u2, m, and then whatever the v is. Hopefully you can see that. And I'm just going to do this now as I did. So my mass for the first object, I'm just going to start plugging figures in, was 400. My velocity was 8, so times 8. I'm just going to put that in brackets now because we're dealing with a plus there. Plus my mass for the second object was 500 times my speed, my velocity was 0. Okay, and then I've got my mass when it was combined, it was 400 plus 500, wasn't it? So it was 900, and then v, because I don't know v. The question's asking me what the velocity is after they move off. And you can see the link here, 400 times 8. Well, I've got 400 times 8 there. I've got 500 times 0, 500 times 0. Okay, so you're just doing it in a different method. It's just this method is much better. And I know it's taken a long time for me to get through this. The second example will be much quicker, I promise. So 400 times 8 was 3200 plus 500 times 0 is 0 equals 900v. I'm just going to simplify this again. I'm going to 3200 equals 900v. You can see how quick this is now. It's like my fifth step and I'm nearly done. I need to get v on its own, so which comes back to the starter. To get v on its own, I divide both sides by 900. So step 6 is 3200 over 900 equals v. Look what I've got. So I've got this step by here, 3200 over 900, only I've got there much quicker. Okay, it's a much quicker process. So I'm just going to rearrange that now. I'm going to bring v on this side, and then that's going to be 3.6 meters per second. Yep, I know. Okay, let's do another example together. And I'm going to try and talk less through it and be more specific about the process. So two ice skaters collide and they move off together. So I'm just going to underline that move off together. So we're dealing with A, B, move in, and then they combine and move off together. So we've got one object after the event. So ice skater A has a mass of 76 kilograms and moves at 4 meters per second. Ice skater B has a mass of 87 kilograms and moves off at 3 meters per second. So we got, after the event now, they're actually moving, before the event, where the other one was 0, stationary, we've actually got two ice skaters moving now, one faster than the other to collide. What is the velocity of both ice skaters after the event? So I'm going to just start like I did before. I'm going to go before and after. By the way, I'm going to do the two methods here. I'm not just going to jump to the second method because I think it's important that I do the two methods. So I've got object A, object B. It doesn't matter what they are. The ice skaters, trucks, it doesn't matter. And then after the event, I've got one combined A, B, okay? One big mass. Let's start filling in my values. So ice skater A has a mass of 76 kilograms. It's got a speed or velocity of 4 meters per second. So it's got 76 kg. And it's moving this way. I've picked the direction again because it hasn't told me. And what was it? It was 4 meters per second. 4 meters per second. Skater B has a mass of 87 kilograms. 87 kg. Got that from there, and it's moving in the same direction, which is important now, at 3 meters per second. So it's still moving in this direction, but it's moving at 3 meters per second. So you can see that this skater is moving faster than this skater, so it's eventually going to collide. And by the way, just as a quick tip to check your answers, when you're calculating the velocity now, the velocity is going to be, it's not going to be more than 4 meters per second, and it's not going to be less than 3 meters per second. It's going to be somewhere in the middle, your final answer. And we'll see if that comes true now. I can also, while I'm here, I'm just going to, because I know my mass is, I'll know my mass for after the event as well. So 76 plus 87, and I've worked this out before, which is 163 kilograms. So I've just kind of done that step there while I'm, I prefer working like this, to be honest. Just going down, linear. Now I can start working out the momentum, because I know the momentum before is going to equal the momentum after. So I'm going to use my triangle again, PMV. Okay, so I'm looking for P, so it's just M times V. So I'm going to zoom in. So P equals M times V. And even on this side now, P equals M times V. Okay, so I need to do the momentum for both of them anyway. So I'm going to start plugging these figures in now. 76 times 4 on this side, it is 87 times 3. Okay, so I've got these values from there for this side. I've got the values from there for this side. Just a case now of plugging those into the calculator, and I come out with 304 there, kilogram meters per second, and I come out with 261 there, 261 kilogram meters per second. By the way, I only did these once, so I might have made a mistake in the calculator here. So if you're coming out, if you're the majority of you coming out with different answers, make sure you leave the comment and tell me, because this obviously will change the answers further on then. So I need to combine those momentums now. So it was PA plus PB is going to give me my total momentum before the event. So I've got 304 plus 261. That's just what I'm bringing from there. 304 plus 261 is going to give me a total momentum, and I can do that as PT if you want, total momentum of 565 kilograms meters per second. Okay, you know, it's a lengthy process to do it the WJEC way, because I've still not, now I've got to reverse that and work it all out in this one now. So my total momentum there is going to be my total momentum after as well. It's just conservation of momentum. So I know my momentum here is going to be 5, oops, let's do my 5, 6, 5. My mass is 163, so PMV, I want to get V on its own, so V equals P over M. Okay, P is on top of M. By the way, these are skills you should have really got from year 10 with Mr. Jeeves there, rearranging these triangles. So if you're struggling with that, leave the comment and I may have to do a video with that. But I'm taking it for granted now that you know how to do these triangles. V equals P over M. V equals, well, my momentum is 565 over my mass is 163. So my velocity, final velocity is 3.5 meters per second. Let me check that now to see if it's in between my original, so 3.5, is it in between 4 and 3? Yes, it is. And that, so I kind of know I'm in the right ballpark there, because this is a faster skater, this is a slower skater. You'd hope that his speed or her speed would carry this one a little bit faster. So the combined speed then, and because their masses are very similar, okay, you're not gonna, that speed is gonna be, or velocity, I keep saying speed, I should say velocity, that velocity is gonna remain sort of constant. I'm going to do it the other way now. I know this video is quite long and you're probably all getting bored. You can do it in 2 sittings, can't you? So you draw a line under that. I'm going to go with my favourite way now, which is M1U1 plus M2U2 equals M1V1 plus M2V2. You're probably there saying, that looks like VZ, doesn't it? That is the number 2. Probably saying, Mr. Timothy, why are you doing this now when we've only got one thing here? Because this is the equation you really need to remember. It's not in the front of your exam. And that is the full equation there. I can simplify it because my objects move off together after. So before, after, okay? So M1 V1 plus M2 U2. What happened there? I think this has run out, is it? Reflector, where you gone? Still recording, I think. Here we are. Look. Gee. There we are. M1 V1 plus M2 U2. That should be U there. Equals MV. That's just my computer giving me the hint that this is taking too long, but it is what it is. So I've got one mass moving off there with one velocity. I'm doing these steps, but you can really avoid that step there. You can go straight to this step. And then I'm just going to plug in the values. So my mass for the first one was 76 times my velocity was 4 meters per second. I'm just getting these values from the original place there. My mass and my velocity for the second was 87 times 3. So plus 87 times 3. Okay. Equals my mass after was 163 because they were combined 163 V. See how quick this one is now. So 76 times 4 was 304 plus 87 times 3 was 261 equals 163 V. Okay, when I combine those I get 565 equals 163 V. I get V on its own, so I gotta divide both sides by 163. So 565 over 163 gives me V, and then I'll just swap V over this side, and then the answer comes out to be 3.5 meters per second. That's a 5. Okay. You try one before you do the assignment and we'll look at this together. So as you can imagine, this will be a really long pause. Try it both methods, okay? There's no harm. Practice makes perfect. You need to invest the time to get it. You really do. It doesn't just come easily. Well, some people it might, but that's because they've got the math skills there probably that they've invested time in before. So you don't just get it naturally, you need to put the work in, you really do. Two trucks collide and move off together. Truck A so move off together. We're dealing with the same thing here. Okay, they're going to move off together. So these examples are going to be exactly the same as I've been doing, just different numbers. Have a go, press pause. All right, so this is the way that I did it before. My first method, so I'll just run through it. 500 kg, 450 kg, he's not moving, this one is. I've worked out my momentum. I've totaled my momentum. I've used this momentum this side to work out my velocity. Okay, I've combined the masses there. So I've got a total mass of 950, which is on the bottom there because V equals P over M. My velocity here, my momentum is from this side. So that's why it's 4500 over 950. That gives me 4.7. Does that make sense? Well, the masses are fairly the same. You'd expect it to be somewhere in between 0 and 9. And that is around about 4.5. So yeah, 4.7 is a good estimation there. Okay, So I think that answer is correct. Then I'll do it my second way there. Okay, you can see M1, V1, or U1, I should keep saying. So I've just plugged the figures in there and I've come out with exactly the same. So my mass from my first one, my velocity from the first one, my mass from the second one, my velocity from the second one. This is after the event. Okay, come up to 4.7 there. If you're not getting it, practice makes perfect, and look at some other videos. They might do it much better than I have. It's just one of those things. It's just one of those things. The process is the process. You'll find that you need to maybe need to practice this 5-6 times before it actually clicks. But this really, this method, this second way of doing it, is the way that we're going to have to do it, because this one only works for this type of collision where they move off together. Okay. All right, let's move on to the assignment then, and it's not a big one this way. It is literally one question. I want you to do one question because we're going to get more practice in this anyway. So the question is there. Your first question: two ice skaters collide and they move off together. Ice skater A has a mass of 45 kilogram and they move at 6 meters per second. East is giving you a direction there, but again, you know, what is important is that that's east and that's also east. So it's essentially the same direction there. Okay, what is the velocity of the two after? Then you challenge there. You're just dealing with bigger number, you know, or smaller numbers, I should say there. Just a bit of a challenge for you. So if you want to submit the two, that's fine, but you're only being asked to submit one here because it's quite lengthy. So the first one we'd really like to see, or I'd really like to see, and then if you can have a go at the second one, that would be brilliant. Okay, so good luck. Any questions, don't be afraid to leave comments or just email directly. Yeah, good luck.